Welcome to the second lecture of York, Pennsylvania, Level 2 Earth Chemistry. Electrons are layered. In other words, they fly at different levels. If they gain energy, they will move out a level, and if they lose energy, they will fall back down a level closer to the nucleus. These levels are called orbitals. The first orbital can hold 2 electrons. The second orbital can hold 8 electrons. Lithium has 3 electrons, 2 in its first orbital and 1 in its second orbital. Fluorine has 9 electrons, 2 in its first orbital, because the first orbital can only hold 2, and 7 in its second orbital. The periodic table is an ingenious way to organize elements. Elements are numbered from 1 all the way down to 102. These numbers represent how many protons are in each element. The rows represent how many electron levels are present for each element. The columns represent how many electrons are in the outermost layer. For example, fluorine is going to have 2 electron levels because it's in the second row, and there's going to be 1, 2, 3, 4, 5, 6, 7 electrons in its outermost layer. Fluorine also is going to have 9 protons. Chemical formulas are written as symbols. They indicate what elements are present, how many atoms are present for each element. Each element is represented by 1 capital letter and sometimes a lowercase letter in addition. For example, H2O has 2 hydrogen atoms and 1 oxygen atom. Since there is no number written past the O, that means there's only 1 oxygen atom. Another example would be C6H12O6. That means there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. This is also sugar. When atoms share or transfer electrons, chemical bonds form. You can think of it as atoms being stuck together. The first chemical bond is an ionic bond. An ionic bond is one in which electrons are transferred from one atom to another. Sodium chloride is another name for salt. NaCl stands for sodium chloride. Sodium has 1 electron in its outermost level. Chlorine is 1 short of fulfilling its outermost level. So sodium is going to give its 1 electron to chlorine, and chlorine will take it. When this happens, sodium is going to have an overall positive charge, and chlorine is going to have an overall negative charge. Positive and negatives will attract, and this will form an ionic bond. Okay, so thinking about the sodium chloride example as being an ionic bond, what do you think an ion is? Take a minute and think about it. An ion is an electrically charged particle. In other words, there is an uneven balance between protons and electrons. It either has more electrons, which will give it a negative charge, or it'll have more protons, which will give it a positive charge. Ions are electrically charged atoms, which means there is an uneven balance between protons and electrons. If there are more protons than electrons, it would be a positive charge and be a positive ion. If there are more electrons than protons, it would have a negative charge and be a negative ion. The next chemical bond is called a covalent bond. Covalent bonds share electrons, so they don't give them up and they don't take them, they share them. This means that the electron is sometimes flying around the first element and sometimes it's traveling around the second element. Our example is water, H2O. Hydrogen normally has one electron in its outermost shell. Therefore, it only wants one more in order to fill its outermost shell. Oxygen has 6 electrons in its outermost shell, and it needs 2 more to fill its outermost shell. Therefore, the hydrogen atoms are going to share their electrons with the oxygen atoms. So sometimes the electrons will fly around the hydrogen atom, and sometimes it'll fly around the oxygen atom. So here oxygen has 6 electrons in its outermost shell. It needs 2 more to get the full 8 electrons. Hydrogen only has 1 electron orbital, therefore it needs 2 to fill its outermost shell. So the hydrogen will share its electron with the oxygen. So now the hydrogen has 2 electrons sometimes, and the oxygen will have 8 electrons sometimes. Every proton represents an element. If there is 1 proton present, that makes the element hydrogen. If there are 2 protons present, that makes the element helium. If there are 3 protons present, it makes it lithium, so on and so forth. Isotopes have different numbers of neutrons, which changes its atomic mass. Atomic mass is protons plus neutrons. That gives you your atomic mass unit. Hydrogen has an atomic mass of 1. Normally, hydrogen has 1 proton and no neutrons, so it has a mass of 1. An isotope of hydrogen, however, might have 1 proton plus 2 neutrons. That would give us a mass of 3 atomic mass units. That would be an isotope because it has more neutrons, therefore a higher mass. A molecule is the smallest physical unit of an element or a compound. This will consist of 1 or more atoms in the element or 2 or more different atoms in a compound. For example, 2 atoms of hydrogen share an electron with 1 oxygen atom to form 1 molecule of water. So 1 molecule could be H2O. 1 molecule, however, of hydrogen gas could be H2. 1 molecule of oxygen gas could be O2. A compound is a type of matter that has properties different from the properties of each element in it. For example, if we have hydrogen gas, it's flammable and it's a gas. If we add oxygen to it, which will make it now a liquid and non-flammable. So the properties have changed. It went from flammable and a gas to non-flammable and liquid. Diatomic models are made up of 2 atoms. So H2 is a gas and O2 is a gas. So there are 2 oxygen atoms there, and in the other example there are 2 hydrogen atoms. Mixtures are materials that contain 2 or more substances that are not chemically combined, which means they are not sharing electrons. In other words, they can be separated easily. For example, air can be separated. We can have tubes of pure oxygen, or we could have tubes of pure hydrogen. Salt water can be separated. If we allow the water to evaporate, that'll leave the salt behind. a bag of sand and rocks. That can easily be separated. A solution is a type of mixture in which one substance is dispersed in another. So, for example, salt water, where the salt is dissolved in the water, or sugar water, where the sugar is dissolved in the water. And last, an alloy is a solution of two or more metals. So, for example, brass is made out of copper and zinc. Chemical properties describes how one substance changes when it reacts with another substance. The key word here is reacts. If there's a reaction going on, it's a chemical property. For example, the chemical property of iron causes it to change to rust when it reacts with water and oxygen in the air. Another example of chemical properties would be flammability. Physical properties do not react with other substances. For example, if I take a sheet of paper, some physical properties would be that it's smooth, it's white, it's rectangular in shape, its volume is 8.5 by 11.5, the density of the paper. Those are all examples of physical properties. Temperature would be another example, density, buoyancy, volume. These all can change, but it will not change the actual substance. For example, if I take a sheet of paper and I rip it in half, the volume will change, but it's still paper. If I change the temperature of the paper, it'll still be paper.